Welcome. This is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium, which took place in Kuala Lumpur, Malaysia. This conference is made possible through the support of the PKI Consortium Post-Quantum Cryptography Working Group and our sponsors SSL.com, Entrust, Keyfactor, HID, and Crypto4A. And with exceptional organizational support from SSL.com, Keyfactor, Logius, POS Digicert, Baker Tilly, MSC Trustgate, and Digitoris. Join the discussion. Join the PKI Consortium. Go to pkic.org/join.
All right. Welcome back, everyone. And again, good afternoon, good evening, depending on what's the mood right now. So rolling on to our next panel, we have on stage 3 panelists moderated by Sven. PQC in practice, right? Why this, not why that, right? So I'll have Sven, who's going to be the moderator, Sudha, Corey, and Tarahiko, who are going to be helping with the panel. Sven.
Thank you. All right. Thanks for coming, everybody. I guess we'll sit down and just kick into this. So why don't we start from Toddy over and just do a little introduction for those that don't know you?
Hi, I'm Tadahiko from Secom. I work for C platform or IETF for standardization. And also I'm a member of the Japanese cryptographic evaluation called CryptoRec. Yeah.
Hi, I'm Corey Bonnell. I work with Digicert and focus primarily on industry standards. Very active in CA Browser Forum and IETF and a couple other venues as well. It's very excited to be here.
Hi, Sudha Iyer. I am Chief PKI Engineer at Citi. I am also involved in international standards for DLT and cryptography in smart contracts specifically. And then I'm a member board of directors at X9.
And I'm Sven Ryla, the International PKI Administrator. I work at Keyfactor, helping customers around the world do fun things with PKI, and pretty big evangelist, I'd say, in PKI. And just like hanging out with a lot of PKI people to do cool PKI things. So with that, let's kind of jump into the first question here, which is, you know, we're all into PKI here, so why are we not considering the use of symmetric keys instead of asymmetric keys as an option?
So let me talk about that. So PKI is like, I think we all agree PKI is very scalable and it's good for some ad hoc like grouping or new people, new like entity joining things. But like if we like, so for like current PKI to some quantum resident something, like we think we have a several options, but I think PKI is most general, or PKI or public key crypto is most general and plausible approach. So for example, like if we make the data to like anonymous, like for like we use some anonymous anonymity technology and to make that like risk to reduce the risk or breach, it's okay, but it's damage like usability of the data. If we can, like if we don't store data, we kind of eliminate, like not eliminate, but we can reduce the risk of the data breach. But those approach can be like would be very like damaging usability, or sometimes it's not possible by the law or something. So those like very scalable approach is not good, like not good for usability. In the other hand, for example, like not using public key crypto, for example, symmetric key or QKD or whatever, like usually they damage scalability. So like, well, it might be good to use in some particular purpose, but I believe if you are using PKI for information system, at least when you design it, like you think you need some scalability or something. And like, so if it completely changes, you might be able to like migrate to like PQC algorithm to instead migrate to other like symmetric key algorithm instead of PQC algorithm. But like I think it's not happen generally. So it's very rare case. And also, like, I think there is another option for, like, for example, like harvest attack. That is, like, for example, like store like encrypted data in the physical access, like in very secure physical access, like control, like, but it's really damage like scalability, and I think it is like not applicable for most cases. So overall, like, for example, internet work like was like spread that much, like because of the support of public key crypto. But I think or I believe like people are using more data and more variety of data and more data size in the future. So we shouldn't like cap those kind of scalability. Yes. And if we cap those scalability, I think we will limit growth of our community. And I think it's not good. So I think we should use public key and PKI. Yeah. That was it.
Great, thank you. So then, we hear a lot of words, phrases, acronyms, et cetera, about PQC. Let's establish some terminology for this panel, so common definitions, and we're going to hand that over to Corey to get this stage set for us.
Yeah, thanks, Sven. So I think, as we go into this discussion, kind of maybe setting some common terminology and some common concepts might be very helpful. As Tadahiko alluded to, public cryptography is uniquely suited for a lot of the challenges that we see. So we're going to focus primarily on PKI. When we're talking about PKI, we're talking about digital certificates, X509. So when we're talking about X509 and the potential approaches for the PQC migration, you might talk about pure algorithms for like a PKI hierarchy. For example, the use of like pure RSA or pure MLDSA if you want that quantum resistance, which means in the X509 context, a single certificate, single key. You might also hear another approach called composite, which is thinking of two separate algorithms, which would generally be one is traditional. So for example, RSA, and another one is MLDSA. Those are combined to be kind of be thought of as like one cohesive and atomic key and signature pair. And whenever you're performing operations like a signing or keygen or verification operation, those two separate key operations are always carried out simultaneously in a very particular way, such that they're treated as one atomic unit. Another concept that you hear of is hybrid certificates. We have Chimera. There's other approaches that have been considered, such as Chameleon. Those generally are thought of as a way of having a single certificate or multiple certificates that have different keys in them, but the keys are used not necessarily together. You might have a one-event approach. For example, you might have an RSA signature, a device that's producing an RSA signature because it hasn't been upgraded to support MLDSA yet. And you need a way to verify that signature. So you might use, a Chimera certificate to do that. Alternatively, you might have, a device that using that same certificate would be able to verify an MLDSA signature. So with its support of reading specific information encoded in that certificate, specific to the MLDSA key, it would be able to perform that quantum resistant verification. So I think there's kind of a little bit of a difference in approaches. I think one thing to keep in mind, at least in my mind, when thinking of the differences is you use composite when you're able to upgrade all your components in a given infrastructure, but you don't necessarily 100% trust each constituent algorithm. So for example, if you're worried about, at maybe a fundamental level, you don't have full trust in some of the mathematical primitives used in MLDSA, you might want to back that up with using RSA. Or for example, even if you trust the math, you might not fully trust a particular implementation. For example, if your crypto implementation has a side channel where the private key can be recovered, since these are newer algorithms with newer implementations, they might not have been battle tested yet. You want to be able to fall back on that battle tested code that you would get through RSA. So with that, you kind of think of composite as I'm able to upgrade all my infrastructure, but I don't have full certainty of full trust in a particular algorithm. And then hybrid is the case where I'm not able to upgrade all my components at the same time. I might have things lagging behind, but I still need that interoperability. At least in my mind, that's kind of how I picture things, and kind of mirrors somewhat from what I heard from the IETF as well, at least when discussing these various approaches.
And now that we're kind of into the next question, we do want to open it up too, that if you do have questions, please raise your hand to get a mic from the moderator to ask, because we kind of make this interactive. I mean, that's the whole fun of designing and having these conversations, that there's a lot to put out there and there's a lot of questions and we like answering them. So with that, we'll give the next one out, is what should be important to your business today in terms of PQC?
Yeah, I think this is a very key question and important one, because we are at the transitional era of internet as a whole. So designing your systems and how you operate and what is critical to you is definitely important. From a financial sector standpoint, I think your transaction processors, your product processors, your trade processors, all these would be your core and important business areas. And then anything interacting with them would be like your settlement processors would be the important ones. There are additional things which are around it. On the other hand, if you are on a telecommunication sector, the only important thing and the lifeline of their business would be just communications and how they are dealing with communication. So it depends from which flavor of industry you are from. But it kind of connects both the things, like which one is better than the other. So I think buying time at this point of time is more critical than just implementing stuff. Even if you implement some kind of CDN solution, to get it to production, it will at least take 1.5 years if you're doing it correctly. So until then, what solution can you implement? So you would need some kind of an encryption from the app level or some kind of open PGP, which is already published, to start building that additional layer of encryption before it is relayed out. And then at the same time, work on your PQC initiatives to shore up the other components, including the public key infrastructure. And I like the point about hybrid and the different variants, the which is what I was talking. One is the Chimera and the other one Chameleon. So Chimera relies on backward compatibility. Most of the banks, especially the SWIFT network, it has proprietary cryptography. So you would need, if you are influencing somebody like SWIFT, it is easier for you to influence them and say that, hey, why don't you start with hybrid? And then we can work towards composite later. In case of blockchains, I think it's easier to have a composite right from the start, because then the consensus and the multisig and all the other architectures become easier to operate. Again, it's all layered, right? You always have to think the architecture of any core system in layers. You could have a root CA with a pure or a composite one if you don't rely on MLDSA at all, and you think that there would be one more algorithm which is going to come in the future. But still, something like a root CA, you don't change the certificate until 30 years. I don't know if people keep indefinite certificates there. And then the other layers probably could have different variants of your hybrid implementation. So I think there are options, but then depends on what is your focal point.
So what are the pros and cons of the Chimera composite and pure strategies and the challenges that we think we're going to be running into? Who wants to take it first? Toddy?
Yeah. Yeah, there are so many pro and con for each of them. But like for pure, like simplicity is like the pro. Yeah. And they like in ITF they just finished standardization of MLDSA and because but like it will take time for standardization of the composite certificates. The difference comes from the simplicity or complexity. So when you are implementing, simple is very good. Yeah, simple is very good. So it should be easier to implement for us. Like you're saying, like we need to like buy time. And in terms of that, like it might be good to use pure, at least for first step. Yeah, even if you want some hybrid one, it might be good to like migrate to the pure first and then move to the hybrid one or another, in my opinion, to buy a time.
Yeah.
In the other hand, like for composite hybrid things, like there are many pro and con, and yeah, I think Corey knows like that. Like Corey can explain the best about that things. Yeah.
Yeah, we are all looking at Corey.
Yeah, we're putting Corey on the
Wait.
spotlight. Come on, Corey.
Wait a sec.
Sorry.
One more thing. I think it's very important that to aware of who pays the cost, which means who are willing to work to or implement or for the PQC migration. For example, like for composite things, like standard body or many people standard body need to work hard and also implementer need to implement, but like they are just changing algorithm. So it might be not necessary to dramatically change architecture. So those people might not need to work hard. In the other hand, some other protocol like application developer may need to work and it might be very hard for them. For example, small companies, application developer, they don't have any clue about cryptography. And it might be hard for them to work over that. And it might be not appropriate to require them to work. And I think that is like point we need to think about. Yeah. Sorry about that to interrupt. Yeah.
No problem. No, I really appreciate the context that Tadahiko gave. I think maybe we'll dive into the composite thing first before we talk about each individual hybrid detail, because I think there's one fundamental question that needs to be answered by an organization. It's that, do you fully trust MLDSA? Do you fully trust these new FIPS approved algorithms? And I think your answer to that is going to guide your implementation approach. For example, if you do not have full trust in MLDSA, maybe not even the algorithm itself, just maybe in a particular implementation of it, you're worried about implementation errors, you might want to elect for a composite approach. And that's when you're combining those two algorithms, MLDSA along with the traditional one, and use that. If you have, full faith in the post-quantum algorithm, but you might not be able to touch all the different components at the same time. And when I'm talking about the different components, you might think of a system as like, having all your devices trust stores, for example. If you're distributing new root key material, you're going to have to go and update the trust stores. You're going to have to go and verify all your cryptographic libraries to support MLDSA or whatever algorithm you're going to be using for post-quantum. And then also, too, you're going to have to upgrade your application libraries potentially that those devices are using. And also the applications that are built on top of those libraries potentially. So there's all these different touch points that have to be considered after that initial question of whether or not you fully trust the PQC algorithm. If your answer is I don't fully trust the PQC algorithm and I'm able to touch all the different components of my architecture, then probably composite is the natural answer for you, because what that provides then is that fallback protection to a legacy algorithm that all your devices already support, but then also provides that post-quantum protection as well in the event of a break for traditional. If the answer is a little more nuanced than that, you might not be able to update all your components. You might want to consider a hybrid approach. And that's where, you're issuing, multiple certificates to basically identify a single device or user. You might have an MLDSA certificate and an RSA certificate, or you might consider, if your application software supports it, you might want to use, Chimera, which is, it's been standardized in X509 a couple of years ago. And that's a single certificate. It has the same, subject identity information in it, but it has 2 keys in it, and potentially 2 signatures if it was also issued from a dual key CA, a Chimera CA. And that allows for selectivity at the application layer on which signature or key is going to be used for either verification or for encryption and decryption. And then if you want to maybe look at a different approach, mentioned briefly Chameleon, which hasn't been adopted yet by the IETF, but I mentioned it briefly. It's just it's a way of conveying 2 certificates with 2 discrete keys inside one certificate. So what that buys you is a lot of software and applications expect a singular certificate. They don't expect multiple chains, and that's a way of encoding both certificates to represent a single entity inside a single certificate. And then also there's other approaches as well that are being considered, such as cert discovery, which has been recently adopted by the IETF. And this is where you actually you can have a certificate point to another certificate. So, for example, if you have an RSA certificate that was used for SMIME, but you want to obtain that sender's MLDSA certificate, they can actually add a pointer to their MLDSA certificate within the RSA certificate, and your email client can go and follow that, grab the MLDSA certificate, and then use that for future correspondence. So there's a couple different approaches that can be used, both from a migration context, from just basically dealing with legacy components, but then also allowing for that upgrade that can be done, piecemeal. So I think there's a bunch of different approaches that can be used. So.
Yeah, I just want to add a little bit of complexity on this because practicality, or what was the word you had used? Adaptability, applicability, actionability and feasibility are two important aspects that need to be considered. It's not just the security aspect, right? How easy is it to govern 2 keys? Currently, we are struggling to govern 1 key. And then like how quickly will it break is also the other aspect, right? If you have dual key control, who loves dual key control by show of hands?
Oh, it's so much fun. I love it.
Yeah, so composite dual key control. So you have to have both the parties, you have to have both the keys. And if both the keys are not generated at the same time, you are basically not providing a service. So I think a more practical approach is the hybrid one, wherein what I would ask our supply chain or the vendors would be to start abstracting this. I mean, you go in any direction, but then abstract the keys from the implementation so that option 1, 2, whether you composite or whether you hybrid it, I don't really care. I just need the key management to be completely abstracted from the PKI implementation. So whoever is the thought leader here and the designers, please do that. But if it gives the ROI, because if I implement hybrid now and I have to change that, or composite now, I have to change that, there is a lesser chance of investment rather than if I have a long-term investment wherein there are abstract infrastructures there. And tying to the use case of SMIME, I mean, it perfectly sits. There is a lot of stickiness in that S-MIME, and I think Tadahiko will touch upon that.
Yeah, so it's bit like apart from the pro con discussion or something, but like the things I was talking with Sven or Corey and previously was like S-MIME protocol. Like that protocol is like very complex. They have a like at least 3 functionality. So signing protocol and like communication encryption protocol and archiving protocol. And those 3 protocols have a completely different like requirement. So we all know like encryption and signing has a like very different like requirement for PQC migration. So yeah, well, because of the Harvest attack. But an archiving protocol, they therefore archiving, so need to be archived for a long period. But for authentication of like authentication of the counterparty, this is authentication protocol for once. So it's very different from like archiving and authentication. So like if they all stick together and make a requirement, the requirement would be very, very heavy requirement. But if we make split those 3 like functionality and migrate, like for example, like one by one, it should be like lighter requirement, although it's like complex. But like so, like for S-MIME, we need to like not only S-MIME but for any information system, we need to kind of spread out functionality and to try to deal with like one by one, I think. Yeah. And it's difficult, like for most of the people. And for that, like especially small company or whatever company. So I think like those kind of procedure should be done with standardization body or big company or something. Yeah.
Yeah, S-MIME is a solution, but then I think I have a ex-colleague here, Peter, who actually built the architecture at Citi for S-MIME with user certs and all, and the distribution part of it. So I think there is it's a big animal of its own, wherein it starts growing with the number of user endpoints and entities. You have MDM, MAM, OWA, or whatever Outlook or any other interfaces, web plugins and others. So it's not just one solution. It's a whole network of its own. So there is a lot of complication involved, and it just increases in layer. And then there is a legal aspect to it, which gets on a different layer as well. I think it's just exponential, and some solutions like EJBC really help in covering most of things. So I'll point that question to you. What is your opinion about S-MIME?
I defer to Tadahiko usually for that one. Yeah. I mean, my opinion of S-MIME is that it is a lot more complicated, like you said, that it's the 3 aspects of like that. And I'm just trying to think, like, how do you really go about that? You know what, I could end up using 3 different strategies with that.
Yeah, I think, one thing both, Suda touched on the key management aspect, and then Tadahiko broke down the different 3 different ways, the 3 different components of S-MIME. One thing that's really interesting is, when you talk about RSA, you can both do the signing and encryption with S-MIME with a single key and certificate. You can't do that anymore with the algorithms that NIST finalized. You're going to have ML-Chem for your key encapsulation.
Exactly.
Used for encryption, and then you're going to have ML-DSA, most likely for your signature component. So really that ability to use a single key, a single signature to do both the signing and the encryption operation is just no longer possible. So it's going to actually increase the complexity, and it's going to underscore the need of better key management.
And abstraction.
We got a question.
Since we were talking about the migration strategy, here.
Oh, there you are. Sorry, the lights are blinding me.
Okay. Since you are talking about the migration strategy, what are your thoughts about let's say I have a certificate that is issued using the classical RSA approach. So what are your thoughts on upgrading the certificate to add another signature inside the existing certificate and then just sign the TB sign data with the PQC key?
And
So you're saying you're issuing a certificate.
Basically, I'm asking about, like, I have my certificates, let's say document signing certificate,
Okay.
that is already issued by the CA,
Right.
and that is using the RSA keys, right?
Yes.
So what is your thought on like upgrading my certificate to add the PQC signature inside it?
Okay, so we're talking Chimera here then. So Corey, why don't you hit that one first?
so when you say add, you mean replace or?
No, it's append.
It's like a pen, so
Append,
you're
but
like you're
later on.
reissuing
But
it
later
from.
on, I'm talking about the append of the signature, but later stage, maybe after 2 months, 3 months.
I mean, I would look at that. You'd have to issue a new certificate, so you could
You
end up making
cannot
a.
just append signatures on a certificate.
Yeah, it'd
Since
be,
I can sign the TBS sign data, like.
Yeah, you can do multi-sig. Definitely, you
that's
can have
why-
your other CA sign the document again, but it doesn't really.
So I'm just asking about your thoughts on this approach.
So if I understood your question correctly, we're talking specifically about the certificate. We're not talking about any signed data or anything like that.
I'm just talking about the certificate.
Okay. Yeah. So in that case, you would have to reissue the certificate from the CA, because then you would have to add the your alternative key within it. I think before considering that, seriously considering that approach, you need to step back and say, well, does the receiver of my of future signed documents, are they able to process like an MLDSA signature? And if that's the case, and you're able to produce MLDSA signatures, those different discrete components are already quantum ready. I would say just move to potentially a new pure key, and don't even consider hybrid potentially. What that would gain you is definitely simplicity. If you're not able to do that, you might want to consider. You could consider using composite, where you regenerate a new RSA key alongside a new MLDSA key, and especially if you don't fully trust MLDSA yet, and you're also worried about a quantum break for RSA, you could consider composite in that regard, issuing a certificate with that single key, but with two new constituent components. If you're not quite ready to make that leap yet, you can consider a hybrid approach, for example, using Chimera, where you would reissue the certificate with a newly generated MLDSA key alongside your pre-existing RSA key, and then use that. That would allow you potentially to have that interop with legacy components, but then also allow you to potentially create MLDSA signatures that would be trusted by parties that can process those.
Yeah, but that's a good approach as well. Like if you're starting to test, I think if you want to separate the use case from the CA itself, that's a good use case. You have a document signing, and then you just stand up another PQC CA, and then just have one more signature on top of it. It still protects your signature, right? It's not a bad design.
And for document signing or long preserving things, actually you can put like timestamp or something over the old signature or something. And if timestamp in PQC algorithm, those all components will be protected. So if those potentially, you can secure those procedure, like you may able to make those documents like quantum resident. Yeah, there are several approach.
Yeah, I mean, we touched upon buying time, right? So if you don't want to change the entire architecture and you still want to parallelly build the other infrastructure, that's definitely one of the solutions that you can take.
Possibly need to think about final destination.
Yeah.
Or where you want to go, and then what time you left. How you buy time would be. It seems to be important. Yeah.
Like blockchains, custodial services infrastructure already has the multi-sig for different parties of your settlement or any authorization flow. And that definitely becomes, you can stand up one CA and the issuing CA giving out one composite certificate so that it's making you ready for the future, and later on you can just remove the legacy software once the dependency is no longer required.
Sven, we do actually have some questions coming in online. Do you want us to go through a
shoot,
couple
yeah.
now? Okay, great. So the first one is, will QRQC risk manifest as a sudden cliff edge event or a gradual increase mirroring past cryptographic compromise timelines?
Ooh. What do you think, Corey or Toddy?
All right. Well, I was kind of hoping Tadahiko would take it. He's the cryptographer by trade, but I'm gonna I'll take a stab at it. I think it's gonna be a near cliff event. If I recall, there was a paper that was written, I think by Peter Gutman a couple of years ago, that showed that, you know, even if you upgrade to like an RSA key, it's like a million bits in size for the modulus, it's going to buy you only a couple months, given a certain rate of quantum capability. So I do kind of see it as a a cliff event for those specific operations, encryption and signature. So I think it's kind of, at least in my mind, kind of a hard deadline.
Yeah, yeah. For encryption, like I think like it's kind of emergent risk, but like I'm not quite sure about like authentication. Like for authentication data, like you use those data not that long period. Like sometimes you only use once for authentication data. So, for example, for web PKI, we shortened identity certificate to the 47 days, and like replacement cycle of the root certificate would be less than 10 years, and like it we are quite agile situation, and for that purpose I'm thinking we have a bit more time to do like smooth migration. Like in my opinion, where PKI had already bought a lot of time to achieve like crypto agility, like from before PQC. So like now I believe we have some problem with CT log server, and CT log server might be expand with PQC certificate, but like Google is trying to investigate what would be like effective way or something, and we have a time so that we can like I believe we have a bit more time to do that. So for authentication, it might be good to like achieve cryptographic agility. Try to achieve cryptographic agility first. If you can buy like enough time for that, you may have a do something different, I believe. But for other purpose, it seems emerging. But like the things that it's bother me a lot is like there are many prediction of the CRQC or something, but like there isn't like that much like strict academic evidence paper for that like timeline. And whenever I ask to the physician face to face and asking like what is the problem and what is the breakthrough need to be solved, it seems most of them are quite difficult question, like problem. And like, well, I can see like possibility of solving that, but like solving all of them would be very, I don't say unlikely, but it's very challenging. And like, and for some use case, I believe we need to care about that. But we have a lot of use case which it seems we don't need to care about that. So like I really think like it's really depending on use case, and like it I'm thinking like I'd like to think use case driven, like thinking or what we do. Yeah, yeah.
All right. What's the next one, Samantha?
We have a couple questions on hybrid. So if someone's asking about considering PQC's potential vulnerabilities before and after Q day, is hybrid good to consideration? And someone else asking a related question on the challenges of hybrid and recommended mitigation strategies.
Ooh.
Okay, I
Yeah,
can start and then you can follow up. So hybrid is definitely good because if, like Corey already underlined, if your priority is security, if you're in a defense organization or something, definitely you will want to go with the composite option because you would always want dual control and other great aspects of security that you would not have on the business side of things. But if you don't need that everlast steel wall, then you would need to use something with backward compatibility, because I think throughout this session we have several speakers touch upon the partner readiness. So even if you progressed, you cannot have your own network, you cannot do business on your own. You rely on 10 different partners to make that transaction settlement or that voice mail pass through or whatever is your core business. You need your partners and your ecosystem to be able to support that transition together. And that's where the hybrid approach, which is Chimera,
Chimera in the
Yeah.
least. Yeah.
suits best for the immediate next step. And then you would have to keep in mind that, okay, we are starting here, but like Taraiko pointed out, you have to keep an eye on the goalpost, that where are we going to reach after X number of years, and then start working in parallel for that. I think that is the best approach.
Yeah, I think if I recall the question correctly, I think we're talking about, what is the value of hybrid as we get close to a quantum break, I believe. Is that?
I think that was part of it, right, Samantha?
Yeah, that's part of it. They're
Yeah.
wondering just if that's a good alternative to be looking at, and then just wondering, what are some of the challenges around it and recommended mitigation strategies.
Yeah, so I think maybe we'll address the first piece first. Is one thing to keep in mind is that we're talking about hybrid. We're generally talking about a traditional classic algorithm paired with a post quantum algorithm. In the event of a break, the security value of that traditional key is going to be essentially zero. So after that quantum break, you're really fully reliant on the post quantum algorithm. In terms of the complexity, a single key, single certificate, pure hierarchy is always going to be the clearest approach. So a hybrid one is going to incur additional complexity. What's interesting is, I think someone mentioned it yesterday, is, pure is the simplest. It's closest. It maps closest to what we have today with traditional algorithms. With hybrid, you're kind of bringing in these new things in the X509 that don't necessarily exist yet. So I would say that, just the absence of robust tooling right at this point for a hybrid, I think, is going to be the biggest thing. For example, just until earlier this year, we did not have MLDSA or any of the other FIPS algorithms in OpenSSL. There were a lot of challenges with just even experimenting with those post-quantum algorithms. Once that improved tooling came into place, people could start playing around with pure. I think that's going to be the same thing with hybrid, is just the absence of tooling that we have right now is going to be the complexity.
The next one I have here is, there's been no history of any crypto change that was not backwards compatible. So is pure PQC without backwards compatibility a viable enterprise solution?
No.
Ooh. I think eventually it's going to be. I mean,
Without a backward compatibility?
I love breaking compatibility, but I know a lot of people don't.
Yeah, unless you change the business model completely, you're changing the architecture and the way you operate completely, then probably you would not need the legacy holding you back. But until then.
Yeah, I think that's actually, I agree exactly what Suda was saying. With composite, after a quantum break, you're going to be potentially carrying around this RSA key that's providing no additional security value. It's increasing implementation complexity because you're going to have all these devices out there that you might have this composite key trust anchor in there. It's going to have software in there to verify like an RSA signature. That stuff's old and it's not providing any security value after a quantum break. I'm going to see it largely as akin to carrying around code right now to verify SHA-1 hashes. It's not providing much in the way of security value. And probably after a quantum break, we're going to see the same thing with composite. But what composite provides us now is a framework for future algorithm migration. So,
It's a stepping stone.
exactly. Yep.
Yeah, and I would just add on to a few use cases which would not need backward compatibility, like your offline system, air-gapped systems. You can start building composite with that because there is no dependency, there is no backward compatibility required there. And something like your blockchain systems, wherein cold storage and other option, cold vault, and few systems like that. I think this is a great opportunity for Cisco to have its SUDI keys also be changed to something with the composite keys.
Great. And we have, well, for now anyway, one last one. Do you think harvest now, decrypt later, resistant PQ forward secrecy cipher suites delay post-quantum readiness preparation?
Can you read that one more time?
Absolutely. Do you think harvest now, decrypt later, resistant PQ forward secrecy cipher suites delay post-quantum readiness preparation?
They actually are complementing it. How are they delaying?
PQC cipher suite means like not only post quantum quantum resistant public key crypto, but also AES and SHA-1 and no, not SHA-1, SHA-2 or SHA-3. Those like set of the quantum resistance cryptography, or like just saying like PQC, like quantum resistant public key crypto.
Are we asking? Yeah, the question is a little blurred. So I think, is that the recipe creation for the cipher delaying the adoption of the TLS itself? Is if that is the question?
It's an online question, so
It's taxonomy things, but like even United States, like CNSA was saying PQC cipher seed, like PQC cipher seed, and it means PQC as a like cipher seed of like AES or SHA-2, SHA-3 or like those PQC public key crypto. But some other NIST standards like document PQC just means public key crypto, like quantum resistant public key crypto. So those like terminology is like very confusing. And yeah, I think that it's not like discussion topic, but like I think it's good to think about that. Yeah.
Maybe again, similar to that, I think maybe what he was asking was if the MLChem, the key encapsulation, is quantum resistant, is that going to delay the adoption for MLDSA? Because authentication is not a priority right now, but you are you still have a quantum secure communication happening in a harvest now, decrypt later, which means.
So MLChem things like actually you can use MLChem or like composite MLChem and ECH like now, and Cloudflare is using.
Yes, that's right. Because almost 40% are already using it, which is sort of quantum secure from a communication perspective. Would that potentially be enough or considered enough, which could potentially delay a post-quantum signatures for?
I believe that is the like individual like topics, and I think we can deal like parallel. So we don't need to delay or whatever. Yeah, um, yeah. So I
Yeah,
think
so
we
how
can
the
do.
key is packaged and reached to you does not really protect how you use the key. Is They are two different things. So Chem can only give you the keys.
Wait, Mike, please. Mike. Thank you.
Sort of gives a false sense of protection that I'm quantum secure in terms of communication, not on the authentication, right? So would that, again, this is my version of whatever was there. So with the short-lived certificate and the value of authentication time, or rather the time for authentication reducing, and the communication being encrypted.
I believe that is like really depending on priority. So we don't like any company do not have like infinite amount of budget. So which information system you will prioritize might be effect, but so if you only have a budget for one information system, it might be good to start for some encryption, something for encryption. But for encryption, at least for communication, it shouldn't be that expensive, in my opinion. And you can do for authentication things parallel to that. Yeah.
I think one aspect of that is definitely good, and that is something that everybody needs to do. It's a CAB forum mandate, so you would have to have shorter lifetime, and that is a mandate because of the quantum threats as well. So yes, it is one compensating control, but then it's not a full mitigation control. And understanding and accepting that it is just a compensating control is the first step, I think. And then you can look towards your goalpost.
Yeah, and also 47-day cannot be achieved without automation. So if you cannot automate some procedure, I think you need to act very fast. Yeah.
Corey, it looks like you want to add something to that.
Oh, I was just going to agree with Tadahiko that, automation, I think, is going to be underlying all these initiatives, both from a policy change perspective, but then also to assist with a migration to PQC. So I think it's really coming back to the fundamentals and reevaluating those. One thing is maybe I think I heard the mention of TLS in that question. I think when we talk about harvest now, decrypt later, that is the most urgent thing that we have, the most urgent problem that needed to be addressed, because you could have an entity now collecting all the traffic, and then after a break going, X years in the future, having that harvested traffic, and then they can go and decrypt it and retrieve content that was, transmitted today. In the case of TLS, the authentication component is done online. With increasingly short-lived certificates, it's done at TLS handshake time. So there's not a high level, as high level of urgency there to move to securing the signature verification piece on the certificate chain. But as as quantum capabilities evolve, especially we know that it's just a matter of time that they do. It's important to ensure that that piece is also being addressed. So I wouldn't say it's necessarily delaying. I would just say it's a recognition and a response to just the level of urgency for each individual issue.
Yeah, and also if we don't do anything, it will consuming opportunity cost. So doing something will be good. For example, cryptographic agility things, or inventory things, or whatever. But even if that is that seems not that urgent, doing those automation or agility things, those things are very important, especially for high risk asset or those things. Yeah.
Cool. And I think that takes us to time now that we can wrap this up. Yeah? All right. Well, thank you, panel.
Thank you. Thank you for having
Thank
us.
you.